Welcome to Inequalities with Salma, Gabriel, Karina, Claire, and Aiden.
Claire, why don't you define it for us?
An inequality is a non-equal comparison between two numbers or any other mathematical expression.
Okay, so inequalities might be a little scary. There's a reason why they do them as little alligators. But we're going to simplify that down for you. Okay, so there are three main types of inequalities. So there's the sort of less than. So basically, when you're talking about inequalities, it's comparing two different equations. So if I have an equation over here, just any equation, and an equation over here, I know that whatever value this comes out to has to be less than whatever value this comes out to. And it's just flipped on this one. And then this just means that they aren't equal. So one side comes out to one number, one side comes out to another number, and they're just not equal. Okay, do we have an example in the next slide?
Yeah, and also those be the less than or equal to and greater than or equal to.
Yes, so the little dash just means that it's including. They could be also equal to each other. Okay, so really simple one real quick. So basically you can treat this inequality symbol as an equal sign 99% of the time. So as you can see here, if we want to isolate x, we just add 2 to both sides. And then, so then we can just isolate x over here, and we have 8. So x is less than 8. So that's basically saying for this statement to be true, the x, whatever x value you put over here, has to be less than the value of 8. So it can't include 8 because then that would equal, and that's just not what it's saying. We got another example. Okay, this one's got a few more parts to it, but again, with this one, you can treat it as an equal sign. So we'll subtract 3x from both sides. 3x plus 7, this pen is fun, is greater than 28. And then just the same thing, subtracting 7, and you get 3x is greater than or equal to 21. And then you divide by 3, and x is greater than or equal to 7. So again, what this is saying is in order for this statement to be true, for 6x plus 7 to be greater than 3x plus 28, the x value has to be greater than or equal to 7. That's all it's saying. Now this is where it gets a little funky. So most of the time, 99% of the time, you can treat the inequality as an equal sign and not have to worry about it too much. Now, all of that goes out the window when there's a negative. So, but it's not that crazy. So again, we're gonna see if we can isolate x. So we'll leave negative 9x is greater than plus 30. Okay, now this is where it gets weird. So whenever, this is just a rule you have to remember, there's no real explanation for it. Whenever you divide by a negative, you'd think that it would come out to 9x is greater than negative 18. Because that's how it would make sense if it were treated like an equal sign. But this little sign there has to flip.
And one way to think about this is technically you're just moving this 9x onto this side. So it's actually 9x is less than 9x minus 12 is less than negative 30. So if you move the 9x to this side, that's kind of where the negative comes, like the side flip comes from.
Yeah. But that's an easy rule that you can pretty well just remember. And then we'll just finish real quick. And from there on, just solve the equation, divide by 9. X has to be less than negative 2. And so again, just for this statement to be true, x has to be less than negative 2. And that's it.
Yeah, also, you know, it can be easy to think of these inequalities, but there are also ways to visualize them. So let's move back to the first one. So x is less than 8. So in some questions, your teacher might ask you to describe what it'll look like on a number line. So if we visualize a number line, and this is 8, and like 7 and 9 and so on, with x is less than 8, this would kind of look like an open circle and an arrow pointing to the left. And this open circle means it's not equal to 8, but just less than 8. And then the left means it's less than that. And same thing with x is greater than or equal to 7, but on the other direction, if this is 7, this is 6, if this is 8, and then so on. If x is greater than or equal to 7, you can visualize this as a closed circle because of this greater than or equal to sign, and pointed to the right because it's greater than 7. And finally, for that last example, it's going to be on the negative sign of the number line. So when there's -2 and -1 and -3 on this side, and if it's less than -2 and it's not equal to -2, it's an open circle going to the left.
Mhm.
So that basically sums up inequalities.
Why don't we try solving this graphically?
Let's do that. Okay, so solving it graphically might sound a little intimidating at first, but it's actually pretty simple. It's just putting it into a picture and interpreting it. So we'll start with the first problem that we had, which I believe, oh, this pen's a little, x minus 2 is less than 6. So if you want to solve that graphically, all you have to do is start with a regular graph. And so you're going to graph each side of this inequality. So the graph of x minus 2 is going to start, or the y-intercept is going to be down here, y equals -2. And then the x-intercept here at 2, 0. So that's a pretty easy line to draw. May not be as straight as I like, but it works. And then you're going to graph y equals 6. So we'll come up here and we'll say that that is at y equals 6. Okay. So what you're trying to find in this equation is where on this graph x minus 2 is less than 6. So where on this graph do you see this line is below this line? Well, you can see it's all the places over here, and the final place is right here at this intersection. So to find that intersection, you can just set the two equations equal to each other. X minus 2 equals 6. And that intersection is at the point at x equals 8. So then you have to go back to the equation also to realize that it is non-inclusive. So the inequality x cannot equal 8, but it's everything this side of 8. So you're just interpreting that as x is, got it, less than 8.
Okay. Now let's look at another example of using a graph, except these are two non-constant lines, or just more complex. So let's draw a graph. So this graph has a y-intercept of 4 and a slope of 2. So we'll have an x-intercept of -2. So y equals 2x plus 4. And then the other line has a y-intercept of -2 and then a slope of -1. So it will have an x-intercept at -2 right here. So that's not straight, but you get the general idea. So the question is asking, when will this line be greater than or equal to this line? And we're trying to find an x value here. So on what x value would this line be above this line? Well, let's look at the left side first. Oh no, first of all, they intersect right here at -2. So, because you can find that graphically without having to solve it. Sometimes you can do that. So let's look at to the left of -2 right now. Is 2x plus 4 above -x minus 2? I don't think so. Okay, now let's look on the other side. Here, is 2x plus 4 above negative x minus 2? It actually is. So,
How can you please explain to me?
Okay, so if you think about it, this line is right here on this side. And then this line on the other side, -2, is right here. So this is higher than this.
Another way you could think about that is for every x value you put in on this side of -2. So if I were to put in 1, if I were to put in 1 for the equation negative x minus 2, then it would be down here. But if I were to put in 1 for 2x plus 4, it would be up here.
Yes, so any x value, any y value they put in, this line will have a greater y value than this bottom one. So you could basically shape it anywhere on the right side of -2 satisfies this expression. So the answer would be x is greater than -2. But wait! This question is asking when it's greater than or equal to. So we cannot forget the equal side here. So the answer is x is greater than or equal to -2. So this expression might have started out looking very complex, but the answer is nice and clean. X is greater than or equal to -2.
Thanks for watching.
Don't forget to like and subscribe to the channel. If you have any requests or video ideas, feel free to comment down in the section below, or you can contact us via our email address provided by our YouTube channel.